We will study the definition of finite groups. So a group is a set that we will call G. And for finite groups, we suppose that the number of elements in the set G is finite. Secondly, we have an operation on G, which we can call multiplication or star. And that's a map from G times G, the Cartesian product of sets, to G. And it maps group elements G1 and G2 to their product, G1 times G2. So this is defined for all group elements. Next, you have a number of properties. Star is associative. Which means that G1 star G2 star G3 is equal to G1 star G2 star G3. So the order of their operation doesn't matter. Second property is that star has an identity. This means that there is an element E such that E star G is G star E for all G. Star also has an inverse. This means that for all G, there is a G inverse, which satisfies G inverse with G is an identity element, is G star G minus 1. So this is the definition of a finite group. We have all of its properties. Now, we want to show some further properties that follow from the definition. So the first property that we want to show is that the neutral element, or the identity, is unique. Such that we can indeed speak about the neutral element. So how do we show this? Well, suppose we have a neutral element E1, and we have a second neutral element E2, then by the fact that E1 is neutral, this is equal to E2, but then by the fact that E2 is neutral, this is equal to E1, and therefore we have proven that E1 is E2, and the neutral element is unique. Secondly, the inverse is unique. So the inverse is unique. How do we prove this? Let's suppose that we have one inverse to an element G. and that we also have a second inverse to the element G. Then this equation is true. But now we can multiply it with the inverse we want on the right. And we find that G1 inverse is G2 inverse, which is what we wanted to prove, namely that each group element has a unique inverse. These are the main properties of finite groups.